What is time? Time is a measure of non-stop, consistent change in our surroundings, usually from a specific viewpoint. While the concept of time is self-evident and intuitive, the steady passing of events before our eyes, the orbit of the moon around our planet describing its fundamental nature is much harder. Even physicists aren't sure what actually happens when time passes, although they do have a few hypotheses. How does time work? For centuries, time was regarded as a constant, independent force, as if the universe's progress is governed by a single clock. This description of time changed in 1905 with Albert Einstein's theory of special relativity. While the passing of time was already known to be closely connected to space, this monumental theory was the first to combine space and time into a single field, one with measurements that vary depending on the relative motion or gravitational forces of objects within it. Basically, that means time is relative. Is time real? Two people moving at the same velocity will each agree their measures of distance and time match. As one person changes speed, however, they will see the other's measure of time and distance change, even as their own stays the same, without any reason to prioritize one perspective of time over another. This means time isn't a constant universal unit at all. It is a relative measurement that varies as objects move faster or slower, or as they are subjected to more or less gravity. Gravity curves space and time. The stronger the gravity, the more it curves space-time, and the more time slows down. This is why people on board the International Space Station, which is further from Earth's gravity, age very slightly slower than those on Earth. Is it possible to reverse time? Of course, for us to actually see these effects on time, the change in speed or gravitational pull must be enormous. But as an observer accelerates towards the speed of light, unique measures of time become increasingly noticeable. In theory, as a particle approaches the speed of light, we would see its clock slow down. Once it exceeds the speed of light, its clock would, theoretically, seem in reverse from our point of view. From the particle's point of view, our clock would seem to reverse.